G'day guys, welcome back to our latest instalment on our Royal Enfield Model J project. Been a bit of time since the last video. What I've basically been doing in that time is taking everything I've got apart, trying to work out what's good, what can be repaired and what needs to be replaced. Also trying to find parts to replace everything and get it all working again. So let's get into what we've got. So starting right off at the top of the engine, these are our cylinder heads. If you've watched the other videos, you might remember there was two engines that came with this lot of parts. So I've got two cylinder heads here. I had hoped that maybe one of them would still be in serviceable condition, but it doesn't look like that's the case. So the biggest issue is with the rockers. Now if you look at the one that's assembled here, you'll see the rocker set up. So the push rods would come up through these holes, act on these little things. And you can see over here the tip there acts on the valve, and I'll just take that cap off. You can see it moves in this little cast iron piece here with a little valley in it. Now obviously there's two sets. This is the better set here on the bench. I just take those off. You can see it's much cleaner on the shafts there and in the little valleys. Likewise with that side. Unfortunately though, when I measure these, the exhaust side is quite good, but the intake side is worn way out of spec. Sorry, that's the exhaust side there. Now, just move those out of the way. If you look here, I'll just see if I can show that. You can see that little oil hole there. Now, it seems to be the way these operate is oil gets pumped up through that hole, lubricates the exhaust side rocker, and then excess oil runs through this valley to lubricate the other side. You can see, I'll just clear off the garbage there. There's a little valley there which seems to be for oil to drain out. But there's no oil feed on that side. Now, if I just show you on the head here, that's the oil feed to the head. So it comes in there, goes up a little hole and into the exhaust side rocker. Now, on this head, I've got all the rocker assembly removed. So you can see that's the oil feed hole there. So oil comes in there, straight up there, and that comes through. That would be around that way, up through there, and feeds the rockers. When I took this off, that was all full of grit and garbage in there. What I suspect has happened is the rocker on this side was basically getting starved of oil, which is the reason it's worn so far out of spec. Every set of these I've been able to find online seems to have the same issue. The intake rocker is always completely flogged. So this is something we're going to have to improvise a solution to. I did try and make sort of more a Harley Davidson style rocker, which is a tube style rocker on a pin. Wasn't super happy with the results, so not sure if I'm going to go with that. I also have ordered a set of later model rockers from an Iron Barrel 500 Bullet, which I'm hoping I can then remake a set of these blocks in brass with a dual oil feed, so it will actually feed both sides. I have to wait until those arrive to make sure they've actually got the dimensions I need in terms of matching the valve angle and also the distance between the pins over here. So that one's still got a bit of a question mark over it. Moving on now to the barrel. So this is the better of the two barrels. If you remember the earlier videos, one of them I had to take the piston out of it in pieces. It was terribly locked up. That one actually ended up with quite a bit of damage in the barrel, which is understandable. I don't think there's enough meat on it to rebore, so I'm going to go with using this one. That's the piston that came out of it. The rings are all fairly well glued up. I reckon that piston could probably be reused, but I did want to go for a higher compression option. There doesn't seem to be any factory or aftermarket high compression pistons available, although these can still be bought brand new. So what I've gone with here, you can see the dome on that one. This is a brand new piston for a 60 cubic inch Harley Davidson panhead or knucklehead. Now it is ever so slightly larger than this one in the bore, but that will give me just enough to do a small rebore on this barrel, get that cleaned up, put some fresh rings on that, and that should give me a lovely seal in the bore. The dome on this, I have measured it as accurately as I could. It is a bit difficult. I'm estimating I should get around 8.5 to 1 compression, so that should be a bit of a performance boost. Moving on to our crankshafts now. These are the two that I pulled out of the two motors that I had. As you can see, the one on the right looks to be relatively clean. The one on the left looks like it was buried at sea. Both of these cases did have quite a bit of water in them, but the one on the left seems to have copped it quite a bit more. If we look at the shafts over here, you can see the drive shaft on this one appears to be relatively clean where the bearings run on it. There's a little bit of pitting on the top there, but all in all it's actually not too bad. It could probably be reused. Unfortunately, the timing shaft is very rough. A lot of corrosion where the bearing rollers would have sat. Definitely well out of spec. Similar story on this one. A lot of deep pitting and corrosion there on the timing side. Again, drive side not too bad. I do wonder whether perhaps the oiling is quite a lot better to the drive side on these. In any event, I do want to try and increase the performance of this engine a bit to keep up with modern traffic. I do think it needs a bit of a custom solution for the crankshaft, so that's why I've got these parts here. So this is a replacement timing shaft. Now this works very similar to these ones here. So it's basically a taper machined into the flywheel that presses in that way. You tighten a nut on that side, which basically draws it into that taper and sticks it in place. The main difference with this one being from a later model 500 bullet, I think they also use these on 350cc bullets. The bearing surface, so this surface here, or that one there, this is 25 millimeters, whereas the old one, that is 25.4 millimeters, so the old 1 inch. This is the drive shaft. Again, this is a much later 500 bullet. I think this is from the Electra model. I'm not 100% sure about that. Again, this is a 25mm shaft, not 25.4. It has a spline for the drive sprocket instead of the taper on the older ones. It also has this extension here, which is for mounting an alternator. I do want to use that. I want to add an alternator inside the primary case so I can do away with magneto ignition and go to a 12-volt ignition system. In order to fit that, that doesn't have the taper on the other end. It's actually designed to be pressed in from the back. That will require either a custom flywheel or potentially machining the taper out of one of these flywheels, making a straight through with a keyway and then pressing it in from the other side. Not 100% sure yet whether I'm going to machine one of these old ones or make a new one from scratch, so that's yet to be decided. I will reuse this conrod. As you can see, the big end is not very happy. These conrods are actually quite hard to get in the correct length. The later model bullets did use the same length conrod. The only ones I can find seem to be aluminium, which I'm not very keen on using. These are steel, so I will hang on to that and reuse that one. Just finally, this is one of the bearings that I'm intending to use. It's a metric needle roller bearing, so 25mm inside there. It does use an inner ring, so that will be pressed on to one of these shafts. That will be pressed into the engine cases. In order to fit that into the cases, this will require a custom sleeve to be machined and then pressed into the case in order to be able to mount that. Onto our engine cases now. You'll see I've actually got 3 sets of engine cases there when I only started with 2 motors. I'll explain why that is in a minute. Now these are the original two sets that I bought with the bike and the original lot of parts. So this is the one that came out of the second frame. As you can see, it's quite grotty on the outside. Inside, it's actually fairly clean. A bit of old oil in there, but actually it's all quite good. Definitely could be put back into service with little more than a clean-up, except for one thing. So while I was going over this and sort of working out which set of cases to use to build up a motor, I was trying to clean up this surface here. As you can see, someone's been a bit rough trying to take that timing cover off previously. While I was working my way around cleaning that surface up, I noticed that right there. Now that's a crack running across that bolt hole. It doesn't seem to continue into the case over here, so I think that could be corrected with a bit of grinding and welding. Unfortunately, I'm not set up to weld on aluminium, and that would also need to be machined afterwards, which is a little bit beyond the equipment I've got. So I thought I might put those cases aside and use the other ones. So moving on to those, this is the cosmetically cleaner set that was actually in the sort of complete bike that I started with. This is the one that really rough looking crankshaft came out of, and as you can see, a lot of remnants here from the rust on the crank. There's a lot of other sort of chalky corrosion in there. There's also a lot of this stuff which it looked like some kind of a sealant that they'd put in there. They're sort of painted all over the lower half of the crankcases. Not really sure what that was. There was also what looked like silicon gutter sealant around this piece here. It didn't look like this motor had ever actually been run. I think someone had put it together, perhaps not super sure about what they were doing, and made a bit of a mess of the inside of it. I thought, nevertheless, I'll clean those up. Unfortunately though, we struck a problem with these as well. I'll just get them turned around and show you what that is. Now this is the bottom of the timing side engine case. You can see the two big holes there, here and here. Those are the holes for the drain plugs, the sump plugs, and also the oil pickup tubes. Now one of them came out really easy, as they should. The other one was hopelessly stuck in place. It was really badly corroded. I tried using a thread extractor to get it out. It wouldn't budge. I tried heat, same thing. I couldn't get it to move. So I decided I was going to need to drill that out. Now I'm sure some of you might be saying, well, why not just leave it in there? There was, given the amount of grit and corrosion in these engine cases, I wanted to make sure I could get all the oil galleries completely clean, and that was the reason that I was certain it had to come out. Now the way those drain plugs work, I've got a spare one over here. So that's the sump plug. It's a little brass fixture there. It's got a bit of gauze wrapped around it. As you can see, that one's a bit grotty, but that goes on one of these oil pickup tubes, which thread up inside the case there, and then the sump plug threads onto the bottom of that. Now that was the tube, one of the tubes that was stuck. So if you look at, and I've got another one there, you look down those tubes, they've got a hole through the center, goes right the way through the length of that tube. So what I thought I'd do is use that hole as a guide to basically drill that out. I thought that would be quite an efficient way of doing it. What I didn't know at the time is that these have a nasty habit of being over tightened. Now you can see that hole there, that should be round. You can see it's sort of ovalized and elongated. That's from the bottom of that being over tightened and twisted around. I've got another one there. You can see that's quite a bit worse. That's actually necked significantly there, and lucky that that one didn't break off. Now that hole on this one that was stuck was very much in that condition there. What I didn't anticipate is just how much that would throw off the alignment of the bottom of the tube. What that meant is when I tried to drill it, my drill didn't run straight. It ended up popping out up here and actually damaging the alloy beside the thread at the top. Now see if you can see that. It's a bit tricky with the light. That's the front oil pickup hole. As you can see, that's the one that came out clean. So you've got the threaded hole up the top there, you've got the flat surface for the top of that gauze filter to mount against, and that one came out nice and clean. Unfortunately, that's the damaged one. You can see there's a bit of carnage in there. The drill has tracked down towards the bottom of screen as it ran up through that tube. It has bit into the alloy. There's still a piece of the steel tube stuck in the top of that hole, which, even though it's been split in half, it's so badly corroded that I can't get the top piece out. So that would require quite a significant repair. I think the only way to deal with that would actually be to hollow that out from the inside of the case, weld the whole thing up, and then remachine that hole and tap that hole, which is a bit of a big job. So as you could imagine, after finding the crack on one set of cases and then managing to damage the other set, I was a bit worried about how I'd actually be able to move forward with this project. Fortunately, I found this set of cases for sale on eBay, of all places. It seemed to be the only set of Model J cases available in the world at the moment, so I was very lucky to find these. They seem to be in really good shape. Apparently this was a recently refurbished engine. Not sure why it's been parted out. The cam followers appear to be new, which is nice and very clean. Someone's given it a really good clean, which is good. All the threads seem to be good. This surface is a little bit rough, but not too bad. Very workable. It did also have oil pickup tubes stuck in it. I managed to get them out cleanly though. They were also twisted at the holes. It seems to be a real common thing with those being over tightened. So I might have to come up with a solution for that. But nevertheless, these seem to be excellent usable cases. It is a later model case. And I'll just turn that around for you there. You can see these holes here in this little fixture. So it's got this little breather which goes on there. I can only assume that's to deal with oil sumping. These are technically a dry sump system, but the oil tank and the engine case is all contained in the one unit. It's quite an unusual design. I assume that's to deal with something. If the engine's been sitting for a while, it can effectively eject any excess oil from the middle of the crankcase, but we'll wait and see about that. The other thing that's a little bit strange is you can see this passageway here, a little hole there, a little oil passageway on the inside of the cylinder base. Now if we have a look, this is the barrel that I removed the stuck piston from. But if I turn it up that way, you can see this hole here. Now that would line up with that little hole on the cases. And if we look inside the barrel, there's a little hole in there. It comes up at an angle. I can only assume that that's to put a little bit of oil on the piston skirt. I've never seen anything quite like that on an engine before. I'm sort of in two minds about whether I drill that other barrel and add that hole and use that oiling system, or I simply do something with this to either block it off or drill it to relieve the pressure and just defeat that system. I'll have to have a closer look at actually where that oil feed comes from, whether it comes under pressure or it's just using crankcase pressure, and then I'll work out what I do about that. So thanks for watching our little update. In the next one we'll be getting some material set up in the lathe to start making some parts to get this engine together.